Okay, 7.3 volumes. So really this is 7.3b and this is day 2, volumes. And we're talking about revolving around axes. So they're called disks. That's what we're finding. But we're going around either the x-axis or the y-axis. Okay? So for your volume formulas, so I want you to really imagine this. If you have a shape that's touching the x-axis, any shape, like let's say this kind of shape, and it's touching the x-axis. So I'm going to shade it in. Here's the x-axis. And then I'm like, okay, take that shape and then revolve it around the x-axis. So have it come forward around the back and forward and around the back. What would that shape look like? So that shape would look something like, you take that, it would stay at the same place. You take that and it would kind of revolve around this way. And then you'd get like this kind of, oh, you get this like funnel shape, right? And you go like around and around and around. So that's really what we're doing. So what we have made is this 3D funnel by revolving around the x-axis. Do they all look like funnels? No. Do a lot of them? Kind of. So like cones, funnels, something like that. Sometimes they're closed, sometimes they're open. It just kind of depends on the figure. So what hopefully you notice though, no matter what you're gonna get is you're gonna get basically a giant circle. Like you're gonna get different circles. So here you have a big circle, and then you have a littler circle inside, and then you have a tinier circle, and then eventually it's just a dot, right? So you have a lot of circles. Well, how do you find the volume of a bunch of circles? Oh, you do pi r squared. So if you're going around the x-axis, it's pi r squared in terms of x, from x sub 1 to x sub 2. If you're going around the y-axis, like this, then it would be pi r squared in terms of y, from y sub 1 to y sub 2. Okay, so then how do you do something like that? So notice that what I did first is I drew in the area. So you still want to do this part first. You want to find the bounded area between whatever they give you, okay? So that blue stuff is first. And then after that, I draw it going around and around whatever axis they tell me, okay? So always just do the area first and then go around and around. So I'm going to show you, but really this isn't like a copying situation. This is a drawing it correctly situation, because you have to be able to draw it correctly and understand what's happening. Okay, so it looked something like this, right? So the blue part was, so this, here's the line, x plus 1, and then y equals 0 is the x-axis, x equals 0 is the y-axis, and then x equals 3 is right here, that vertical line. And you're taking that blue stuff and you're rotating around and around that x-axis. So it comes forward and then it goes back, and it comes forward and it goes back. What does this look like? Kind of like a cone, but like cut off at the end, right? Like a traffic cone, but like the stubby kind, right? On its side. So when you look at this, I want you to realize you have a bunch of circles. You have a giant circle, you have a little circle, and then you have medium circles. So one of these radiuses would be from top to bottom. So how do you get that top to bottom? You decide. I said it's a y value from top to bottom. So what is the top? It's x plus 1. What is the bottom? It's y equals 0. So x plus 1 minus 0 is x plus 1. And then we plug it in to our formula, which is basically pi r squared. So you can see what happens. You get pi r squared in terms of x from 0 to 3 on the x-axis. Plug it into the calculator and then you can get your answer that way. Okay? Okay, for the next one, you're thinking about first, when you're graphing this, guys, you're thinking about, see how I made a mistake? Okay, so you're thinking about, I want to go from 1 to 5. What are my y values? So my y values, well, I can plug the 1 in and get a 1. I can plug the 5 in and get a 25. So I need to at least go to 25. So I went all the way to 25. Then 5 comma 25 is here. 1 comma 1 would be like really close to the x-axis. It's not actually the x-axis, but it's really close, right? So 1 comma 1 would be like up there somewhere. Okay. And then you're taking that blue portion between 1 and 5 under this y equals x squared. And then you're revolving it forward and back and forward and back and forward and back around the x-axis. What does that look like? It's more like a funnel. Remember we're talking about the funnels? So, or like a blowhorn, right? Something like that, like a horn. Okay, so what's that going to be? Okay, it's a pi r squared. And then why would it be 1 to 5? Because this is x equals 1 all the way to x equals 5. That's our blue portion. I like to draw in a different color for the area so I can really tell what I'm finding from what x value to what x value. And then where did this come from? So top minus bottom is going to be x squared minus 0. So it's just x squared. And then quantity squared, because it's r squared. There you go. Yeah, plug it into calculator. There's your answer. All right. For the third one, this one's a little different. This one, I give you a hint at first, okay? So this says find the volume bounded by, and then it says y-axis. If you're on the y-axis, then what you want to do is make sure everything is in terms of x if possible, okay? So how would you even graph that though? Like, how do you know how to graph this? I don't remember. However, I do know that I can plug a 1 into the y and get x equals 2. I can plug a 4 into the y and get x equals the half. So I can graph it that way. At least I have those two. Okay. Also, what's 2 over x look like? 2 over x in general looks like 1 over x, but, you know, stretched out a little bit. So it should look something like that. So once I have my 2 points, I should be able to like draw what I need. Okay, so again, my points were, what was it, 2 comma 1 and then 1/2 comma 4. So I go ahead and draw my 2 comma 1. I should have a number here and then a number here. Okay, so 2 comma 1 and then 1/2 comma 4. Okay, so it looks something like this, which makes sense because it should look something like that. And then I'm between y equals 1 and y equals 4. So go ahead and shade that in as your area that you're revolving around the y-axis. So this blue comes forward and back and forward and back. So imagine it revolving, revolving, revolving this way. Okay? So that's what you're finding. Okay, how is this different than something like this? Well, it starts off as pi r squared, right? So pi something squared in terms of y. Well, what are your y limits? So the blue is between 1 and 4. So 1 and 4. Okay, is this going to be a top minus bottom? No, it's in terms of y. It's going to be a right minus left. What's the right? 2 over y. What's the left? Technically x equals 0. So you can leave it like that, or you can write it like that. It's the same thing, right? Same thing, doesn't matter. Okay, plug that into a calculator, except don't put y in your calculator, put x instead, because calculators don't like y's like that. So just go ahead and lie to it and tell them that's an x instead. And then there's your final answer, okay? So give that a try, and then we'll do the back tomorrow. So definitely, even though your homework today and tomorrow is basically the same and you're just like continuing, I would say do the first 6 today. Draw the picture just like we talked about in class for 1 through 10, okay? Give it a try.